Hey guys, I have chosen for the Chapter 6 case study critique to use the Mount St. Helens volcanic eruption from 1980. The reason why I chose this for two reasons. One, because to date it still is the most economically impactful, negatively impactful volcano in the history of the U.S., and also because it happened in 1980 and I was alive in 1980. I still remember as a little kid hearing about the Mount St. Helens volcanic eruption and that being kind of part of my childhood in the early 80s. So a bit of nostalgia, but either way, I know this is a negative thing. I'm going to first critique the case study stage by stage as I've done in the past, and I'm going to highlight a couple of articles that I found online. Okay, stage one. It is currently March 1980, and you're the county commissioner of a mountainous region of the country. Obviously, this is the Pacific Northwest in the state of Washington. You've been notified by a volcanologist that multiple earthquakes have been noted in and around the area of the volcano, and it has affected the volcano. And at this point, you're starting to see visibly some steam emanating from the crown of the volcano. It also notes in stage one that there's a large logging industry in that part of the United States, which we all know is from the older forest and the larger trees. So there's a logging industry. Obviously, there's some tourism in that area, and there's tons of residents who live in and around the area. The type of volcano that they mention this is in stage one, it's a composite volcano, which of the three different types of volcanoes is the most dramatic and could cause the most damage. At this point in the stage of the case study, they mention what to do as a county commissioner is to alert residents, to identify your resources, and to begin drafting an evacuation plan, and to ensure that there's communications between you and other local and state, federal government agencies. Make sure that your communications are in place and working. Stage two, it is now April of 1980. The mountain is beginning to show signs of stress. There's a bulging area in the north side of the mountain. At this point, it's noted that the volcano is active and evacuation in certain areas must begin. They also noted, they highlighted during this case study that there was an actual single resident who refused to evacuate even after multiple warnings. And what it mentions about that is that when you have residents who refuse to evacuate after multiple warnings, they are to be essentially and ultimately left to their own devices during the actual emergency, to not risk the lives of your first responders during an incident if a resident or a certain community has chosen not to evacuate during the actual incident, because then you risk the lives of those first responders, which are resources that you need post-incident. It also mentions at this time to begin opening shelters and start positioning your resources in and around the areas that you're going to need them if the incident actually happens, which of course they knew at the time that it would ultimately erupt. Stage three, it's now Sunday, May 18th, and the volcano explodes. There were little earthquakes, some minor earthquakes prior to this, which showed the seismic activity within the volcano. There was some steam. There was a big portion of the top, the corona of the volcano, actually degraded, and it began showing signs of the north face of the mountain of the volcano actually getting blown off prior to this. But this was the official start of the volcano. And ultimately, you would find in the case study, it mentions that as the county commissioner, you would find out that over 230 square miles would end up being destroyed. During this time of the volcano, even though it is actively erupting, you still need to continue your evacuation efforts. And at this point, you need to begin search and rescue operations for areas that can ultimately be helped and saved. Also, it mentions that the public must be kept informed during all stages of this. Scientists need to be contacted to begin and to continue monitoring and studying. And you must also keep in contact with additional government agencies for aid, local areas that are outside of the blast area, and state and federal agencies because of the aid that they can supply. Highlights of this case study were a lot like some of the other natural disasters that we've highlighted. Volcanoes can't be predicted. You have an idea that they may erupt, and you might get an increase in seismic activity, but ultimately you can't predict when a volcano actually will erupt. At the time that it erupted, it was a Sunday, so the logging industry wasn't working, so there were no loggers on the mountains, which ended up being a positive thing. And it mentioned that you must have an effective evacuation and emergency response plan, which is obviously the theme of every single case study that we've done. You need to have an emergency response plan ready for any and all contingencies. Ultimately, 57 people were killed, which isn't a lot, but the economic impact was huge. There was estimated 1.2 billion, or I'm sorry, there was 1.2 billion feet of ash that were thrown into the atmosphere. But ultimately, let me find it right here. The economic impact was very dramatic. I'll actually cover it in my next section because I found that information from a separate source. I found a couple articles online. The first one was from a website called usvolcanoes.com, and it mentions a couple things. It mentions the actual seismological events. For example, there was a magnitude 5 earthquake that was accompanied by a debris avalanche, which turned the upload and confining pressure at the top of the volcano by redoing the cryptodome. What it's saying is that once the top of the volcano was blown off, now you have less pressure pushing down on the magma from underneath, so there's a negative pressure, and so that's what creates the magma to rise. It also mentions that the first sign of activity was a series of small earthquakes, which is what I mentioned earlier. Let me see here. The volcano's northern bulge, as these small earthquakes were happening on the northern side of the volcano, there was a bulge that was protruding from the side of the volcano, and this northern bulge and summit slid away as a huge landslide. The day of the the day of the volcano, and it was the largest debris avalanche on Earth in recorded history. And recorded history is about 2,000 years, so that's a pretty big landslide. And it mentions that the total volume of this avalanche was about 3.3 billion cubic yards, which is equivalent to 1 million Olympic swimming pools worth of ground, melted water, ice, sliding down the side of a mountain, which is pretty dramatic. The lateral blast, which is the blast off of the north end of the volcano, devastated an area of 19 miles from west to east and more than 12.5 miles northward from the former summit. It mentions that virtually no trees remained within 6 miles of the summit in what was originally a very dense forest. Let me see if I highlighted anything else. Yes. What I found particularly interesting was that the ash cloud that erupted May 18th blew 520 million tons of ash eastward across the United States, and what it noted was in about 15 days, the ash cloud encircled the entire U.S. That, I thought, was pretty dramatic information. The next article that I found, it's called Mount St. Helens Erupts, Facts and Information. It was written by Mary Bagley as part of the Live Science website. I believe it's also a publication, but I found it online. What I found interesting in this article was that volcanologists, during this time, this is 1980, you understand that this is 30 years ago, so technology isn't what it is today, but at the time, volcanologists used reflective targets and lasers to record changes along the volcano. What they did was they set up these lasers and reflective targets on the volcano, and these lasers were set miles away on different cliffs and summits of the different mountains and hills and ranges that are in that area. And they used these lasers to identify any movements along the edges of the volcano, which would, of course, indicate seismic activity. On the morning of 5/18 of March 18th, volcanologist David A. Johnston, who was camped on the ridge within the direct blast zone of the volcano, he was studying the volcano, monitoring with the lasers. He sent in his last radio transmission, quote unquote, "This is it." So he was within the blast zone. He was recording information on the volcano. He noted the increased seismic activity along with the laser information, which told him that the mountain was about to go. He radioed in, "This is it." He sent a little bit more data over his radio transmission. That was it. He was within the blast zone, so he obviously died. As a matter of fact, everything within 8 miles of the blast was wiped out almost instantly, which is pretty impressive. And as I mentioned earlier, economically, this was the most destructive volcano in U.S. history. 200 homes were destroyed, which isn't really that much. But 185 miles worth of roadways and 15 miles worth of railways were damaged. And more importantly, if you factor in the timber industry, civil works, and agriculture, the losses were estimated at $1.1 billion. And this is, of course, 30 years ago in 1980. So if you use inflation, we're upwards of $2.5 million worth of damage back in 1980. So that's the information that I found. I also provided a YouTube video, a link to a video on YouTube, which it was about a 22-minute video, but it was video footage before, during, and after the volcano eruption. It was pretty interesting. I'm not from the Pacific Northwest, but I have a brother who lives in Seattle, and he tells me all the time that he wants to go do hiking, camping, and bike riding along Mount Rainier, which is another volcano that is within, 7-8 miles, or you can see Mount Rainier from the summit of what was then Mount St. Helens. So they are along the same volcanic ridge, seismic ridge, which includes the volcanic activity. He wants me to go camping and hiking in that area, and based on the information that I found, I'm probably going to tell him no. But thank you guys. Have a good one.